So far in our factoring journey, we've only had to deal with positive numbers, meaning every part of our expression has been positive. We haven't been able to deal with subtraction or negative numbers, but those are things that come into play. So I just really quickly want to review a couple of things about negative numbers when it comes to multiplication that might be important. A positive number times a positive number will always be a positive number. This is probably the first thing that you learn about addition or multiplication, but not directly. It's kind of implied. The next two are pretty much the same. A positive number times a negative number or a negative times a positive will equal a negative. If you have one negative number anywhere in your multiplication, it will turn the whole thing negative. However, if there are two negative numbers, a negative times a negative, those negatives will, as people say, they cancel each other out, they undo each other, and you're left with a positive number altogether. So two negatives, when multiplied, turn into a positive. So let's look at an example that will have a negative number here. Let's say we want to factor the expression x squared plus 3x minus 10. Okay, big emphasis here on this minus 10. So we're going to have to deal with a whole new set of things. So our C value here, the value at the very end, the constant term, is negative 10. And then B is still just 3. So since C is negative, since the thing that we're looking to multiply to is negative, it has to be one of these, right? If it equals a negative number, we have a positive and a negative, or a negative and a positive, which is essentially the same thing. So one factor must be negative. As I look at the math, the multiply to, I want to multiply to negative 10. I want to add to 3, and that'll tell me my factors. So we can go ahead and look at the factors, the numbers that multiply and equal 10, and that'll kind of help us out here. We have 1 and 10 and 2 and 5, but we don't have negative 10 on here, but we can use 10, and that'll pretty much give us the same thing here. So let's go back to this screen. So 1 and 10 was one pair of numbers. Remember, one of them has to be negative. So either the 1 can be negative or the 10 can be negative. Same thing for 2 and 5, right? Both those multiply and equal 10, but one of them has to be negative or the other has to be negative. So from here, it's just taking these pairs and figuring out which ones add to 3. So if I add these instead of just putting them next to each other, negative 1 plus 10, 1 plus negative 10, negative 2 plus 5, and 2 plus negative 5. You're going to notice a very interesting pattern here where this is positive 9 and this is negative 9. This is positive 3 and this is negative 3. So, it doesn't change the absolute value of the number. It just determines whether or not it's positive or negative. So the numbers that add to 3 are negative 2 and 5. So the factors are negative 2 and 5. When I write my factored expression, because the 2 is negative, because it's not positive, it's negative 2, I'm going to write x minus 2. The 5, however, is positive, so I'm going to write x and then plus 5. If it were negative 5, I'm going to write x minus 5, but that would be our final factor form. So you'll notice that we pretty much have done the same thing that we've been doing before. This is nothing new here. The only thing to keep in mind is that negative numbers do change the factors a little bit. So when you look at your factor sheet, when you look at this factor sheet, you may have to say, well, if I need 7, or I need negative 7, I may have to look at positive 7. If I need 58, or I need negative 58, I'll just look at 58 and assume one of them is negative. So just kind of a shortcut that you can take instead of having to look up negative numbers or deal with that all.